All right?
Okay, sir. Okay, sir. So, can we start, sir?
Yes, you start, please.
So, good evening, everyone. Welcome to the 44th webinar of FCTL webinar series. As we already know, this series is all about sharing the idea, knowledge from the alumni of FCTL IIT Kharagpur to the students or even the working professionals in the field of food science, food technology, and food engineering via this online platform. Today, I would like to welcome our speaker, Professor P. Srinivasa Rao, sir, Professor in Agriculture and Food Engineering Department, IIT Kharagpur. Actually, I remember my first class in IIT Kharagpur when Professor Rao sir has taught us HPP, high pressure processing, under the non-thermal processing course. And after that only, we all were excited to join that course. And I guess more than half of our batch has joined the course. And both Professor Mishra sir and Rao sir has taught this course very well. And we get so much knowledge about the non-thermal processing. So thank you, Rao sir and Mishra sir, for teaching us. And even Rao sir was our faculty advisor at this time, and sir has mentored us very well. So thank you for this. So now before the formal introduction, I would like to invite Professor Viswanathan Rao sir to say a few words about Professor V.S. Rao sir. Professor Viswanathan.
Good evening, everyone.
Good evening,
Professor
Good evening.
Mishraji, Professor Srinivasa Rao, and all the scholars of the Incubation Facility Center. So, Professor Rao is well known to me, at least for the past more than 2 decades, and Dr. Mishra almost since 1982, when I was a PG scholar and he joined as a research scholar in the same department and center. So today's topic to be delivered by Dr. Srinivasa Rao is important, and still we cannot say it is a emerging field. It has reached the status of implementation or application, we can say. This high pressure applications. I still remember it was sometime in 2006 when the first phase of the World Bank funded program, NATP, National Agricultural Technology Program, was over. The next program, National Agricultural Innovative Program, started in 2006. So there were many components like conducting basic researches, taking the research findings to the field, and solving the problems from the production to consumption in the marketing or in the network, market network. So this topic came under the basic research, and there were a lot of competition among the various institutions, and it was IIT Kharagpur, SIFT, Cochin, and Kerala Agriculture University, Thrissur campus. They were the partners. I still remember. Yes, we had one interactive meeting. Interactive meeting at Sifat Ludhiana, where all the competitors were made to meet for a 2 days workshop to refine their program. I was there as one of the experts, and like that they got it. And if you see in the advanced level laboratories, Ohio State was I think the premier institute which started working on this high pressure processing. Ohio State, especially Professor Sudhir Sastry, Professor V.M. Bala, they still continue their work on high pressure processing. Of course, V.M. Bala was our alumni from TNAU.
Yes.
He has taken a number of scholars from India and guided them in the area of this high pressure processing. I understand that Professor Rao also there for some time to undergo some advanced level training program at Ohio State University.
No, sir, I just had a visit for a few days.
You see. So, without taking much of his time, where we can listen to him about his experience in this area and get the knowledge. So, I take the opportunity of involving me also to offer some remarks on this today's event. I welcome Dr. Srinivasa Rao to start his talk. Thank you very much.
Thank you, Professor Viswanathan, sir. Thank you, sir, for your words. Okay, so before the webinar, we have some formal introduction about Rao, sir.
Although Professor Rao doesn't need any introduction.
Yes, sir, but
He is a very good authority in the field of food engineering, food processing, internationally recognized. And I have the honor, I think he is my second M.Tech student. I have the
Second, sir.
second, first was PG Patil and this second M.Tech student of mine, so I have that pride. But yes, continue, Siddharth.
yes, sir, okay. Dr. P. Srinivasa Rao is currently working as a professor at Agriculture and Food Engineering Department of IIT Kharagpur and has more than 27 years of teaching and applied research experience in food process engineering and technologies. Before joining IIT Kharagpur in 2004, he has served BCKV Mohanpur for 9 years in various positions. He has been the leading Indian researcher in the field of non-thermal processing, especially high-pressure processing of food materials since last 12 years. He has supervised 15 PhD students. Out of them, 2 theses have been awarded with Jawaharlal Nehru Award, Outstanding Doctoral Research by ICAR New Delhi. He has published more than 104 international and 9 national research publications in referred journals, 10 book chapters, and 1 edited book volume. Also, he has 1 granted patent and 2 filed patent to his credit. Even Professor Rao sir has many awards in his hand, like Distinguished Scientist Award in 2019 and Fellow in 2020 from Andhra Pradesh Academy of Sciences. He has also received prestigious Dr. Yelavarthi Nayagama Memorial Award 2020 from Science City of Andhra Pradesh. So, participant today, it is a great opportunity to listen him in this 44th FCTL webinar. So I would like to invite Professor P.S. Rao sir to present his webinar on topic research opportunities and challenge in hydrostatic pressure processing of perishable foods. I will request the audience to mute their mic and close their video during presentation. However, they can post any queries in the chat box, which will be addressed at the end of the webinar. Professor Rao sir, the stage is yours.
Okay, thank you. Let me share my screen.
Yes, sir.
So, is it visible?
Yes, sir. Yes, sir. It is. Yes, sir.
1 minute. I think. Is it just
but-
mode or visible?
It is visible, sir, but it is not in full presentation mode.
Now?
It is not in the full presentation mode. Means
Now is it? Now.
no, sir.
Slideshow mode.
Okay.
So during the
That's
presentation,
F5.
That's fine actually.
sir, please unpresent it.
You have to unpresent and then unshare and then reshare entire screen.
Okay, sir.
Entire screen हाँ तब आएगा.
Yes, sir. तब आए.
आप जब एरो बटन प्रेस करोगे तो आएगा इंटायर स्क्रीन.
Yes.
इंटायर स्क्रीन को प्रेस करो, देन बटन रीएक्टिवेट ग्रीन हुआ होगा, उसको प्रेस कर दो. आई थिंक देन इट विल टेक. शेयर को प्रेस करो. You press entire screen and then share button activate हुआ होगा वहीं पर नीचे.
Is it not visible now? Full screen?
Not it. अभी present share button activate करो. Share.
Yeah.
Not It is not coming yet. Yes.
Yes, sir.
Yes, now it is. Up go to the presentation mode.
Oh, left the meeting.
N Mishra.
सर प्रेजेंट नाउ में कि योर एंटायर स्क्रीन का एक ऑप्शन आएगा, उसमें क्लिक कीजिए. Now yes, sir. Now it is visible.
Yes, sir.
Yes, it is visible, but you are unmuted now. You are muted. Please unmute.
Is that okay?
Yes, sir. Now it's okay. Now it is fine.
Okay. It's complete screen or maybe in other sides loader also is there.
No, sir, it is complete screen now. It is
Okay.
complete.
Great. Thank you.
Thank you, sir.
Okay. First of all, let me express my gratitude to Professor Mishra sir and the FCTL team for inviting me for this webinar series, and on 44th webinar I am just give. And my topic for today's discussion is research opportunities and challenges in hydrostatic pressure processing of perishable products, where I'll be sharing my little experience which we gained in last couple of years. So as all of you know, so thermal processing is of course very well established and of course being employed in most of the industry. While we get the microwave safe products, but the quality degrades due to thermal abuse, and the quality in terms of loss of color, loss of flavor and functionality. So these are the kind of issues with current thermal processing. And whereas the consumers, they are always interested in the current scenario for the high quality products with fresh like sensory attributes, and preferably with without any kind of additives or maybe chemical preservatives. And of course these products should be ensuring the safety, and this way actually meeting this demand obviously needs some kind of alternative technologies. So these non-thermal technologies have of course is picking up in a big way. So the classical example of meeting the consumer need for today's fresh like products is high pressure processing of avocado. This is actually one of the very potential product which is being produced in US particularly, and of course it's sold world over. And when you talk of the emerging technologies in food processing, there are of course a long list of them, and many of you are aware, and particularly students who attended my course, probably I might have discussed all these things earlier. But for the people who are new to this platform, so just I would like to tell some of them. These are hydrostatic pressure processing, high intensity pulse electric field, pulse light, oscillating magnetic field, ultrasound, cold plasma, etc. But of all these, high hydrostatic pressure processing is of course is one of the most adopted or maybe commercially which is being taken in a much forward way. So that way actually it is gaining much popularity. So when you thought of any new technology development to meet the existing issues, so it must be competitive in terms of having an advantage over the existing ones. Even non-thermal processes, so they can be used for the inactivation of food spoilage microorganisms without affecting the quality of food. So where high pressure processing or maybe high hydrostatic pressure processing, it play a major role, and this hydrostatic pressure processing is a novel method of non-thermal processing for the preservation of food materials, particularly the perishables. So it is receiving wide attention all over the world. So it has several synonyms, as many of you are aware. So like HPP or hyperbaric pressure processing, ultra high pressure processing, pascalization, so like this. So and of course it's most commonly known as high pressure processing. So the high pressure processing works on three basic principles. Hydrostatic principle, where it says the application of pressure is instantaneous and uniform throughout the sample, which is the major advantage in terms of applying the pressure without much delay. Secondly, the Lee-Chatter's principle, where the reactions resulting in a volume change are influenced by high pressure applications. So due to the compression, what is happening in the high pressure, so that will be leading to whatever the changes in terms of microbial inactivation, in terms of enzymatic destruction, even like, so whatever the functional changes which are happening, all these are because of the volume change. And of course, the third one is principle of microscopic ordering. When the temperature is kept constant and increasing the pressure, so this will actually is proportional to the degree of ordering of molecules, which will bring a lot of changes in the structure and microstructure of the food materials. Now, as you know, the high pressure processing is nothing but application of food materials at very high pressures, like elevated pressures to the tune of 900 megapascals, which is equivalent to 9,000 atmospheres. However, this process can be adapted with or without addition of heat, basically to achieve microbial inactivation, as well to alter the food attributes to achieve the desired qualities. So the applications are of course vivid, and of course depending upon the individual's need. So people might be applying different ranges of pressure with a wide range of timing also. So the pressure processing, of course, as I mentioned earlier also, it is applied at ambient condition, or maybe it can be applied at lower or maybe higher temperatures. So that will be suiting to a particular situation. So what's happening actually when you are applying high pressure processing, in terms of chemical bonding, covalent bonds are intact, they are not affected due to the high pressure. However, the bonds like hydrogen bonds, hydrophobic interactions, electrostatic interactions, these gets affected. Due to that, we will be getting the intended changes. So ultimately, it is to achieve the microbiologically safe product along with the maybe enzymatic safe, and it will retain the nutrients while retaining the sensory attributes like flavor. So high pressure processing can be considered as an alternative, not today, maybe at a later stage. So the major features of high pressure processing is the products are actually processed in a packaged condition, pre-packaged condition, and the application of high pressure processing renders the food shelf stable due to inactivation of both enzymes as well as the microorganisms. And the sample actually in a pre-packaged condition is inserted into a vessel where actually a lot of hydrostatic fluid is being, any kind of liquid actually can be employed there, and that's why actually the process is called hydrostatic pressure processing. So the pressure applied is through some kind of hydrostatic medium. Most commonly it is the water. However, there are alternative fluids also. One can use alcohols also. One can use aqueous solution of glycols, etc. Even sometimes people use even lipids also when you are intending to increase the temperature. Now the major advantages are this can be employed on both liquid and solid products, but in flexible containers, and it has the potential even for treating the low acid foods. So the treatment of foods in HPP is uniform and nearly instantaneous throughout the food product, which already has been told as an isostatic principle. So during the process, it kills the bacteria and mostly eliminates the heat damage because there is no temperature which is being applied externally. However, there may be slight temperature increase, that's due to the heat of compression. So that's of course a nominal, and of course commonly it is about 2 to 3 degrees centigrade for every 100 megapascal, depending upon what medium actually you are adopting. More important is actually these processes are formulated in such a way that there is no chemical preservatives or additives added to this, so that improving the overall quality of the products. High pressure processing can also create ingredients with novel functional properties and allow the ingredients that would be destroyed by conventional heat transfer methods. That means these the application of high pressure, it can initiate some kind of micropores. In turn, the mass transfer, it can be improved, and sometimes actually the penetration of some kind of solutes also it is possible with this. That way you can have some novel functional ingredients. At the same time, if you are having the heat sensitive constituents, those can be well preserved. For example, ascorbic acid or maybe any kind of bioactives which are otherwise could have been destroyed due to the thermal processing can be well retained. So that's why ascorbic acid rich products or maybe any kind of bioactives included products can be prepared so that these will become more functional or maybe can serve as a health improving products. The unique high pressure effect is of course demonstrated through shucking of oysters, where normally removal of this oyster meat it's quite tedious, and of course normally scooping with sharp objectives. Then So at least 15 to 20% loss of meat will be there. The structural integrity is being lost. Whereas after HPP treatment, you have dual advantage in terms of getting the meat separated very easily, where 100% yield can be possible. At the same time, we are eliminating the microbial loads. Another, of course, potential application is retention of bioactives through high pressure processing application in any of the food materials. And of course, many of you might be aware the factors which affect the high pressure processing is the type of food material. So whether it is, of course, acidic food or maybe high acid food, low acid food, or maybe whether it is semi-solid or maybe liquid food material. And apart from that, what is actually its composition? Maybe if it is having some kind of hard subjects within the tissue, then also it will behave in a different way compared to a complete homogeneous tissue. Similarly, the parameters like pH, water activity, and food composition, these also influence, although not many studies are there on change of these particular attributes. Then, of course, mostly people have simply adopted a particular range of pressure and maybe a combination of the pressure time. And of course, so they have looked at the inactivation of the enzyme or maybe microbes. However, the effectiveness of this HPP process also depends upon the type of enzyme or maybe type of microorganisms that we will be discussing subsequently. And of course, packaging material also play a major role in terms of is in fact we need a flexible material, as I told, but the composition of the packaging material also sometimes controls the volume changes. So that's how packaging material also plays some role in the high pressure effectiveness. Now, if you see the process how it is done, simply as I mentioned, in a flexible packaging material, the semi-prepared or maybe prepared food material is packed, and of course this is put into the vessel, which is a high pressure vessel made of exotic steels, and this vessel is filled with liquid pressure transmitting medium, as I told, preferably water, where the pressure is being transmitted either by continuously pumping the water in the indirect systems or otherwise by pushing a piston in case of direct systems. So this way the pressure is transmitted to the food material uniformly, and the holding time, of course, so it varies anywhere between 30 seconds to even 60 minutes, 90 minutes also, but practically 6 to 10 minutes are actually most commonly being adopted for the betterment of actually process cycle. Inactivation of pathogens and spoilage or microorganisms are the major result of this process. However, sometimes the process is done simply as a pre-treatment for improving either heat transfer or mass transfer or maybe some kind of material infusion. So finally, after completion of this holding period, then depressurization is done. Then of course the cycle is complete. Your temperature, which is even raised during the pressurization due to the heat of compression, also will be subsided or maybe will be reduced to your initial temperature that is actually close to ambient. Finally, the product is removed from the vessel. As I told, the packaging material also, it is very important. So generally plastic films are generally amenable for HPP, and of course so these may not be normally suitable for the high temperature, where actually more than 60 degrees temperature will cause melting or maybe kind of changes in the packaging material. But in case of HPP, metal cans or maybe glass containers which are solid or maybe rigid, these cannot be used. Packaging materials for HHP treatment should be preferably oxygen impermeable so that you can avoid any kind of adverse reactions like oxidative changes of unsaturated lipids. However, there is a need to develop improved packaging materials that prevent oxygen permeability and light exposure for keeping the fresh color and flavor of these treated food products. And when you are developing a new products, some new packaging materials, including maybe biodegradable films or maybe edible films, etc. These are also nowadays being employed in high pressure treatments. But the sealing ability of these materials actually it's very, very important. Otherwise, actually, if the pad fails inside, then it will contaminate the whole of the fluid, and maybe the system you have to completely vacate and of course clean it thoroughly. Now, looking at the microbial efficacy, which is the major concern as far as HPP is concerned. So most vegetative, pathogenic and spoilage organisms can be inactivated about 200 megapascal, and of course temperatures can be controlled within 45 degrees centigrade. Yeast and mold, both of them can be inactivated between 300 to 400 megapascal at near ambient temperatures. Gram-positive bacteria are more resistant compared to gram-negative. So Looking at this, the sensitivity can be classified like this. Yeast and mold are most sensitive, and whereas bacterial spores are actually most resistant. However, in between, the gram-negative bacteria, it is the next step of your yeast and mold, and followed by gram-positive. Again, the gram-positive being high resistant, but rod-shaped are actually less resistant compared to cocci-shaped. So this is actually the order of sensitivity. However, there are actually extreme cases where if you are having some kind of compositional influences, there the order might change. For example, in a sugar-rich product, generally yeast and mold, it shows a higher resistance even compared to gram-negative bacteria. So such are actually extreme cases. Now looking at the effect of high pressure on the food composition, the microbes, as we know, this gets inactivated. The mechanism which is postulated so far is the permeabilization of the cell, or maybe the cell lysis followed by. So this way the inactivation of the microbes are occurring. Starch in presence of water, when it is applied with high pressure, so it gets swollen, and the tissues which is actually soft or maybe moderately hard, they will be disintegrated. So this is the reason where actually water penetration possibilities are there, and you can have some kind of intermediates which can be prepared with improved heat and mass transfer. Then as far as the lipids are concerned, so this can go under transition, whereas proteins, this gets unfolded, and this is the mechanism which is in fact described for inactivation of enzymes, because enzymes are one class of proteins where because of the unfolding of these from primary to tertiary and maybe subsequently. So when you are employing a pressure beyond a particular range, can permanently disable the this unfolding folding process, so that the enzyme will be inactivated. Now looking at the HPP effect on food quality, so individually you can see these are a couple of examples. However, there are several such studies are there. In case of lipids, for example, prepacked fish showed the reduction of FFA and formation of peroxide during the frozen storage, whereas without these treatments, these FFA content as well as the peroxide values are actually increasing even during your chilled or maybe frozen storage. So this is actually one particular. However, there are studies where people have said the lipids presence can even activate your lipid oxidation. So there are actually vivid studies are there in different. This all depends upon the composition of the medium, and even if these lipids are isolated and when they are treated, so there is no such kind of lipid oxidation which occurs. So this is because of the interaction between the tissue and so whatever the lipid which is present. So this lipid oxidation which is occurring. Now in case of vitamin C, HPP protects the ascorbate molecules better than our thermal methods or maybe thermal processing. That's how actually this has been observed. A less than 5% loss in orange and even less than 10% in different food products, which is a major advantage compared to your thermal processing in terms of protecting your vitamin C. Whereas in case of health promoting compounds, HHP has a positive effect on flavonoids and even sometimes showed significant increase in total flavonoids, like actually 34% more in orange juice. This is basically because of the increased membrane permeability and cell wall disruption that's leading to your extractability and release of bioactive compounds. Thus, you are able to estimate a higher amount. So otherwise actually it could have been not possible to get a complete extraction. Now higher efficient in like a lycopene extraction. So that's how actually this HPP is being one of the pre-treatment in nowadays for the extraction applications, where so the tomato waste has been actually extracted for lycopene, where 90% of lycopene could be extracted with a simple 1 minute treatment of HPP at 500 megapascal. So these are actually some major advantages. Similarly, mycotoxins like aflatoxin, etc., these are also can be reduced. So it is a potential tool in reducing the mycotoxins, including aflatoxins. So this couple of studies are there on peanut and other kind of aflatoxins. Now starch gelatinization is another application where HHP results in reducing the gelatinizing temperature of starch. In contrast, the structure of starch granules are maintained by the HPP. So this way actually we are having a dual advantage, and the starch gels which are actually formed by this pressure influence, they show better stability after storage, and even HHP makes denser gels with a low grade of retrogradation. So this is actually another advantage as far as the starch gels are concerned. Now, looking at the quality attributes like sensory, so HHP can protect quality of fresh fruit cuts. So in terms of its color, flavor, texture, and nutrition value, they can be well retained. So this is one of the segment which is actually being researched most nowadays. Now, if you look at these are actually a couple of studies which have been done by Ramaswamy sir, Hosharli. So where the milk actually there is no color difference. Similarly, in case of strawberry also there is no color difference. In case of meat products, where actually protein denaturation might cause some color change, where actually the product gets lighter. So this is actually one major observation in case of meat products like salami or maybe chicken, beef, etc. Whereas foods or maybe milk, etc., even milk products, they actually doesn't express any kind of changes in the color. So for example, you can see here the cheese before and after, so there is no color change as such. Now, some of the HPP products, many of you might have seen in the different papers or maybe presentations also. So like jam, jelly, juices, salad dressings, fish, meat products, etc. Whereas Japan is the largest HPP implementation segment, where actually a lot of products, particularly related to the fruit juices or maybe fruit, cut fruits, etc., or maybe vegetables, these are being prepared in Japan, and of course, so these are available in the market. Similarly, in the European markets, it's predominant with meat and maybe aquatic products. But in US market, mostly it is avocado and some kind of rice cakes, yogurt, etc. These are the products which are available in the US market. So these are actually other examples of your HHP products, and even some of the fruit juices, smoothies, sauces, etc. These actually they can well retain their quality attributes. Now, looking at the application of high pressure processing, there are several of such, and these actually it's not an exhaustive list. Tempering of chocolate, gelatinous of starches already we have discussed. Blanching of vegetables, where actually the major advantage with blanching is there is no leaching loss, and of course, so we don't require to change any of the fluids after the blanching is done. Similarly, tenderization of meat, many of you are aware, it takes a long time in a conventional process, but actually here, because of the this microporation which is happening, so the tenderization can be done at a rapid rate. Maybe it can be completed in a couple of hours instead of several days. Similarly, coagulation and texturization of fish and the meat minces. So this is another segment where actually a lot of gel-based products are being prepared with mince meat. And instant freezing and thawing is one of the specialty application where rapid freezing and rapid thawing is possible without any kind of temperature gradient. Even the drip losses are actually said to be very, very least. And increased water absorption rate and reduced cooking time for the beans. Although it looks like very primitive, but several applications are there in these days, including even the brown rice which has been treated with HPP so that the water absorption can be faster. At the same time, the GABA content actually has been enhanced due to the reactions which are happening in the high pressure processing. Now, pre-cooked rice for microwave readiness, sterilization also is possible with the pressurized thermal processing system. Now, apart from the existing applications, there are a lot of new opportunities in the pressure processing where refrigerated cut fruit salads for healthiness, convenience, and labor savings. Whereas once we are having such kind of organized cut fruit industry is there, so the byproducts can be collected and these can be utilized well. At the same time, new applications are ready to eat or ready to serve products with improved nutrition. So where actually you can have a lot of bioactives embedded into it, and of course you can treat, so that actually these will be serving altogether a different segment. Similarly, the restructured fish products from the underutilized fish species, they contain some amount of meat, but with a lot of bone structures. These are not utilized as a edible directly, but otherwise the separation of this minced meat, this can be actually facilitating that kind of restructured products. At the same time, during the separation of meat, at the same time subsequent products, you will have a lot of cross contamination that also can be eliminated during the restructuring of these fish products. The extraction of biologically active compounds as demand for specialty supplements, functional foods, nutraceuticals, and natural personal care products are soaring all over the world. So this is a great opportunity for utilizing the high pressure technology for the extraction of biologically active ingredients, and of course these are also can be embedded into other food products. So products with improved bioavailability and bioaccessibility is another segment which is of course fast coming, where a couple of studies are there with a mixed results. But however, actually it is very important aspect where based on its improvement of bioavailability and bioaccessibility. So all the products actually which are being treated with HPP can be tested for bioavailability and bioaccessibility. Similarly, it has been proved in some of the cases reduced allergens in the processed food products. It's a great advantage wherever actually we are having allergens, particularly the nut-based allergens. And organic foods, clean label products and baby foods. This is another segment of high-end where actually organic foods are actually very well preferred, or maybe you can say most preferred by consumers these days, since they are having a good quality in terms of as an ingredient, but the same quality should be maintained subsequently also during processing. So that's why HPP can pave way for maintaining its quality. Similarly, clean label products where there is no addition of any kind of salt or maybe other kind of preservatives or maybe additives, that can be avoided by HPP treatment, so that the clean label products can be of better quality. And similarly, the baby foods, generally it's not preferred to have any kind of preservatives. So that's how actually the HPP treated baby foods can extend the shelf life while improving its digestibility and as well as the quality of the products. And as I mentioned already, sterilization is suitable with combination techniques. Particularly the THPP is well known, but you can have other combinations like maybe combination of ultrasonication, combination of pulse light, etc. prior to your HPP or maybe after the HPP, so that this combination can minimize the severity, so that the minimal processed products can be obtained with a greater quality. Now, of course, looking forward, so the components of HPP, just it's for understanding of the newcomers. So where actually the pressure vessel is the core or maybe heart of the system, and the pressure generation system, where actually some group of pumps will be along with some kind of intensifiers, they will be utilized for the pressure generation. And pressure generation can be considered like indirect or maybe direct. And most of the food industry and particularly the lab-based systems, they are all actually with indirect compression systems. Whereas the vessel, it's made with different kind of structures or maybe compositions, where actually monoblock or maybe wire wound systems or maybe core in core. So those kind of actually different kind of systems can be adapted for the high pressure processing. So this is the system actually what we are having at IIT Kharagpur. Maybe I will be showing subsequently. And when it comes to the effect of high pressure, so there are actually different zones of pressures which are being employed for various applications. So if you are interested only for the permeabilization of cell membrane, the pressure in the range of 100 to 300 megapascal is generally preferred. Whereas for the inactivation of the microbes, it will start from 200 to 600 megapascal. For the inactivation of enzymes, we require slightly higher pressures because they are more baro-resistant. They actually the pressure range in the tune of 400 and above. So these are actually generally suitable. Up to about 700 megapascal, these are being employed. For the inactivation of the spores, similar to your thermal processing, here also spores, they are actually most resistant. So because of this baro-resistant nature, so inactivation of the spores is not possible even with 1000 megapascal. Instead, actually, one can go for a combination of temperature with the high pressure to the tune of about 800 megapascal. So that way, you will be having a sterilization effect. Now, as far as the variables which are considered in the high pressure processing are concerned, pressure level is one of the major, where actually you can vary anywhere between 50 megapascals to the highest range of 600 or maybe 900 megapascal, depending upon the equipment which you are using. Similarly, the dwell time, the holding time is considered as a dwell time here, and the process temperature also plays a major role. So the combination of pressure and temperature will have a together effect. And ramp rate, although people have not studied much, but it is also having an influence. So whenever you go for a very rapid preservation, so you will have a much of the inactivation. At the same time, the sterility will be far superior compared to a slow ramp rate. And of course, number of cycles also is another one which is not studied much. Okay? So this is the system where actually you have a console, and this is the vessel system, and this is called power pack, where actually all these pressure generation systems, which are which includes the pumps as well as the intensifiers, etc. These are there apart from the control systems. Now moving further, this is the system as I showed earlier also, and the structure it looks like inside like this, and it is having a complete control as well as the data acquisition provision, so that you can vary the parameter very closely, and at the same time you can monitor the all the parameters. Now this is a typical high pressure cycle in a system. So the pressure is increasing to a desired level. Let us say in this case actually it is 400 megapascal, and it is held for some time. This is called holding time or maybe dwell time. Otherwise, this is nothing but your process time. And of course, you are decompressing. And even it has been told without even holding also, if you simply increase the pressure and of course then drop the pressure, that is called one pulse. So this pulse also is having a good impact on inactivation of the microbes. To be frank, actually about 40 to 50% of the microbial inactivation can happen during your pressure ramp itself. That's due to barrow shock. Now these are actually some of the large scale high pressure processing systems which are both available in both vertical as well as the horizontal modules. So vertical modules are actually that you can load the sample from the top, and of course the enclosure will be there so that you can close the system from the top. Whereas for horizontal systems, most of the industrial systems of higher capacity, more than 200 or 300 liters, these will be with the horizontal systems where the vessel is located horizontally and both end caps are open, and of course the sample will be going inside in a crate. So you can see in the next slide how actually this. So these individual packed products are actually loaded into a crate. The entire crate will be pushed into the vessel, and both sides of the end caps will be closed. And after the preservation, the treatment is done, and subsequently the entire crate will be coming out as a treated product. Now, most of the times actually it is talked of cost is very actually obligation parameter. So cost of high pressure processing, it depends upon the combination of the pressure holding time and temperature at which the product is processed. So higher the pressure, so you will be incurring more amount of energy, and obviously the process severity is more. So you have to actually choose these parameters very carefully so that the cost of operation will be minimum. At the same time, going for very high pressure also will have influence on the equipment health. So that's why actually the highest pressure, although 900 megapascal or maybe 800 megapascal for a particular system is possible, but having all the trials with 800 megapascal is no good. So it has to be restricted so that the equipment life will be saved. The cost per unit production is lower for a single large production unit compared to several small pressure units, which is similar to any other kind of thermal equipment also. So that means a large equipment will be having a lower capital cost in comparison to equivalent several small equipment. Now these are some of the HPP based food products. So it is always said, so good quality is being maintained. So original taste, color of the food, it can be maintained. So allowing the creation of highest quality premium range products. So the real taste of freshly squeezed juice can be released. So that is one of the major advantage with the food juices. Then the HPP products which are available as of now are pomegranate, apple, carrot, broccoli, beetroot, and for that matter actually several other juices like lychee etc. also we have studied here. And the development of natural, preservative free and functional products by HPP is the crux of the HPP process. So HPP allows the development of healthier food, so which is rich in vitamins, antioxidants. Thus it will bring a higher level of functionality to the products. That's why actually some of them can be even considered as a health foods. Now if you see the nutritional quality retention, so this particular graph indicates the retention of vitamin C, folic acid and niacin, which are actually most sensitive in case of thermal processing. So you can see in vitamin C at 540 megapascal, which is higher than even the control one. So this is because of the extractability and during your due to your cell permeabilization, so you are actually able to get higher amount of even vitamin C. The similar kind of cases were there in case of flavonoids also and other kind of bioactives. So similarly, the folic acid, there is no change at the severe most condition of 540 megapascal also. In case of niacin also, 540 megapascal, there is no change compared to your control samples. This way, you can have an advantage of well retention of most important nutritional aspects. Similarly, even during your storage period also. So the green one is actually thermal processed one. During the storage of 20 days, so it has reduced slightly, whereas in case of high pressure processed one, the vitamin C was well retained to the tune of about 80+%. So this is actually a major advantage. That means the stability of these sensitive vitamins is actually is possible with HPP treatment. So some of the applications based on classification, you can have pasteurization, where actually the juices, milk, meat and fish, these are actually generally pasteurized. So sterilization, high and low acid foods can be sterilized with the pressurized thermal processing. or maybe thermoelastic high pressure processing. Both ways it is being utilized. Similarly, some of the applications like texture modification, as I already told, the gelation of the mince meat, etc. So that's possible in case of fish. Similarly, egg also can be converted into solidified egg, and proteins also can be gelled, and starches also they can be gelled. Coming to the functional properties, the cheese, yogurt, surmi, these actually will have an advantage in terms of improving its functionality, where actually the micropores which are being created, you can infuse some kind of salt or maybe other kind of condiments, etc., so that it will be having a better application. At the same time, the improvement of functionality in terms of its digestibility, in terms of its available bioactives, etc., that way the functional changes are there. And some specialty processes I already told, the freezing, thawing, fat crystallization, enhancing reaction kinetics, where actually the slow reaction is there. So again, here also the range of temperatures and maybe the pressure combinations are being shown for various kind of applications. Like freezing and thawing is generally restricted within 300 megapascal, but the temperatures are lower than 20 degrees centigrade. So in case of pasteurization and blanching, the pressure used are up to 700 megapascal, but the temperature can go up to 60 or 70 degrees centigrade. But sterilization generally, it starts with 80 degrees centigrade and can go up to 110 degrees centigrade, while you are employing 600 and above megapascal pressure. Now, coming to the treatment possibilities, the solid foods which are having some flexibility in its structure, where actually the volume change is possible, they can be treated, but with a vacuum packaging condition in a flexible packaging. Similarly, the liquid foods can be treated in flexible packaging, like fruit juices, dairy products, nutraceutical formulations. These can be treated in liquid food segment. But the foods that cannot be high pressure treated are the foods which contains a lot of air and crack, like bread, mouse, etc. And whereas packaged foods in completely rigid packaging, like bottles or maybe cans, etc., these cannot be treated. Similarly, the moisture content is very low, or maybe the water activity is very low. Such kind of products also, they cannot be treated. Rather, actually they can be treated, but the effectiveness is nil. So that way, these are not suitable for the high pressure processing treatment. I hope I'm clear to you, everyone, right? So maybe if any questions are there, you can just post on the chat box. Now, whereas applications of high pressure in the food industry, if you look, so it starts with food preservation and while improving the food safety. But several of the recent applications are allergen reduction, salt reduction, improving the bioavailability and bioaccessibility, improvement of the textile properties, so that you can create a different range of ingredients as well as the final products, reduced food contaminant formation during the process, and high value compounds recovery, for example bioactives, etc. So one of such example is here, the HP is used as a intervention for the extraction purpose. So in the first case, so the food waste byproduct is added with solvent, and of course HP treatment is given, so you can get the extraction where bioactives can be recovered. In the other case, actually the initial byproducts itself, they are treated with high pressure treatment, followed by extraction with any kind of solvent, using the byproduct, using the high pressure processing again. So that way you can have a higher amount of extracts. At the same time, the quality of the extracts are superior, which has been proved. Now, another application, of course, is one of the specialty application, jam manufacturing. Normally, we know unless the heat treatment is done, the gelation cannot occur. But in this case, the freeze concentrated juice is taken to the tune of about 45 degree bricks, then further actually sterilized with HPP. So this HPP in presence of pectin that has actually get the effect of gelation. So these gels are actually soft. That means compared to your normal thermal induced gelation, here actually these are quite soft gels. That means these may not be giving the higher gel strength, but here actually these are little soft soft products are there. Similarly, one product which has been developed in our laboratory based on the Sapodilla, and again here actually we have reduced the TS, these added sugar to less than desired. So actually TSS 45% we have taken, pectin 4.5%, and citric acid about 0.5%, which has actually gave this kind of gelation, and at 400 megapascal for 10 minutes treatment at near ambient conditions. Okay, so these are actually some kind of specialty applications. Then another thing which gelation in application, HP induces gelation of the proteins as well as the polysaccharides. So these gels could be created even at a low temperature. So certain examples are kiwi and strawberry purees have been gelled, where actually you can see this graph. So the whatever elasticity is actually much higher in this case of in case of gels which are formed by non-thermal processing like high pressure processing. Similarly, another gelation example is actually egg, where actually the left side is the egg which is gelled through high pressure processing. You can see the yolk part which is actually uniform in color, whereas thermal one actually the central part is actually more deeper, and whereas the extreme parts are actually lighter. So this way you can have a better quality product and maybe soft gel products using high pressure processing. So some of the research results which we have carried out at IIT Kharagpur, I would like to share in a simple way, where actually we have done research on various commodities like lychee, mango, pineapple, coconut water, sugarcane juice, aloe vera, etc. So some of the results actually we can just quickly go through. So the first one which we did is actually peeled lychee fruits, where actually this you can see the pictorial. So this is the control one without any treatment. This is the one which is treated at 300 megapascal for 15 minutes. So you can see there is no color difference. However, if you see the final finding, you can enhance the shelf life to 32 days under the chilled condition, whereas the without any treatment it can be kept only for 12 days at 5 degrees centigrade. So the conditions which are adopted are 280 megapascal, and for about 6 to 10 minutes treatment was actually good for this particular thing. At the same time, yeast and mold were found to be most barrier resistant in the lychee fruit among the group studied. So the other study which we did on HPP lychee juice, where actually we have applied the pressure in the range of 300 to 600 megapascal, and here actually we have done one deeper study where actually the number of cycles and some mode of preservation also we have changed. So this is actually very rare. You will not be finding much literature on this one, because most of the studies actually it's only application of high pressure at a couple of pressures, and of course maybe for a single time or maybe with a little variation in the time. So these are the most of the studies which are available. But we could understand the cyclic or maybe pulsar pressure also having a lot of influence in terms of either reducing the energy or maybe improving the process efficiency. So that way actually we could find, instead of going for a larger holding period like 45 minutes or maybe 30 minutes, we can go for 1 or 2 cycles of short like 10 minutes, so that actually overall processing time also can be reduced, the energy requirement required also it will be reduced, and of course the product quality will be much superior. So this is actually one of the specialties. So where actually you can see here the double cycle means the same process conditions we are applying twice, and of course let us say this is a 10-minute holding, this is a 10-minute holding, overall it's 20-minute holding. But an equivalent microbial inactivation, we may require more than 30 minutes of holding if you are going for a continuous holding. So this is actually one advantage with holding with cyclic pressure. So this is actually again the HPP lychee juice, the control sample you can see here, and again here actually the severe most condition is 668 megapascal and 15 minutes pressure, where the ramp rate actually we have varied here, and we have seen there is an influence of the ramp rate. Okay, so you can see here the severe most condition also the product is having slight improvement in increment in the lightness, whereas the color wise actually there is not much change. So wherever actually there is a difference in the color, it's because of the expulsion of the air which is entrapped, and that's why actually it is giving a different color. But otherwise actually there is no severe change. Like actually had it been thermally processed, probably a lot of browning could have occurred, and the color of the lychee juice cannot be kept. And the major findings are here. The POD was the most resistant enzyme for both static as well as the dynamic preservation. And similarly in microbial groups, so the least resistant were coliforms, and most barrier resistant were cyclotrophs and aerobic mesophils. And the HPP optimized juice was found to have superior quality, extending the shelf life of about 90 days as compared to thermally treated one for about 70 days only. The untreated could not last more than 14 days. Another study we did is on HPP of mango pulp, where actually the range of pressures were again 100 to 600 megapascal, and the treatment time was 20 minutes, and we have taken, of course, in different levels. And you can see here also, so these are actually under different conditions. This is actually control sample. The control sample is this, where actually these are treated with different combination of pressure, temperature, and time. So this way actually the severity, process severity did not influence the color basically. So 6 log cycle reduction was possible in AMC after 600 megapascal application for about 10 minutes at 52 degrees centigrade. Basically, this is a thermal assisted high pressure processing treatment in comparison to the previous ones, which are only high pressure treated ones. So lightness increased slightly, and 95% of the retention in ascorbic acid after optimized high pressure condition was obtained. You can see the maximum inactivation obtained for PME, PPO, and POD. That means PME was the most resistant, and that way this can be taken as an indicator enzyme, so that actually you can design the process. So that's actually you can see here the PME was identified as the process index for the thermal assisted high pressure processing of mango pulp. The conditions are 600 megapascal, 50 degree and above 8 minutes. Okay. So moving forward, we have high pressure processing of pineapple puree, which has been studied in depth. So for various aspects, where actually we could find a 600 megapascal with a combination of 50 degrees centigrade for 30 minutes or 70 degrees centigrade for 20 minutes. So these combinations could be possible. So if you are not bothering for the microbial count, probably this is good enough. And if you are looking for, if you are looking for the quality, so this is actually the best combination. If you are looking for the microbial stability and enzyme stability, so this combination is actually the best one. And another study which we carried out is on sugarcane juice, where a 5.5 log cycle reduction was possible in aerobic mesophils, and at 600 megapascal, 30 degrees centigrade, and even for 20 minutes. Actually, one thing can be observed here. In the previous cases, actually, we could get a 6 log cycle even with a 10 minutes treatment or below also. But here, actually, we are not getting a good log reduction because of the high sugar content. So even for a 20 minutes treatment, we are getting hardly to 5.5 log cycle reduction. And that's one of the major problems. So the ZP values also, it proved to be higher in comparison to the other commodities. So 92% of the POD inactivation was possible at the taken conditions like 600 megapascal, 60 degrees centigrade, and for 25 minutes treatment. And of course, so the another study was on a mixed beverage, where actually, so we have studied a sugarcane juice with amla combination, and a 500 megapascal, less than 45 degrees centigrade, and more than 30 minutes treatment was good. Here actually, we have controlled the temperature because of the addition of amla juice, which contains higher amount of vitamin C, that we would like to protect. So the temperature we actually controlled up to 45 degrees centigrade only. So we are having actually very good shelf life, about 110 days with this combination. Similarly, we have a coconut water treatment also, where actually we could get a 500 megapascal, 60 degrees centigrade, 20 minutes treatment time for obtaining 40% PPO and 75% POD. And in this case, the PPO was more pressure stable compared to POD, whereas in other cases it was different. So that means even the resistance of the enzymes also, that will be the compositional dependent. So that's what actually we could understand from the studies. So you can, of course, it has been compared here. So these are the actually different commodities which we studied. The resistant microorganism also, it was different in different cases. Although we know the yeast and mold, actually it was the least resistant, and probably it could have been inactivated very easily. But in case of peat lychee, so yeast and mold only, it has been proved to be most resistant microbe. And similarly, POD, in most of the literature says POD was actually resistant organism, whereas we could find even PME also most resistant in case of mango. PPO was most resistant in case of pineapple, coconut, and the combination of such juices. So this indicates the resistant enzyme also, it will be the compositional dependent. And when it comes to the sensitive bioactive compounds, as true with the thermal processing, ascorbic acid was the most sensitive, and in certain cases the antioxidant capacity also, it has been proved to be the sensitive. And the status, in most of the cases actually we follow the chilled condition as recommended in the literature, because we are getting a pasteurization effect unless otherwise we are going for a temperature adaptation. So that way actually, so we have gone for a chilled temperature storage, and of course for a comparison actually we have taken a 37 degrees centigrade or maybe near ambient conditions. So another is the saffron extract, saffron bioactives extraction using high pressure processing. In turn, these bioactives actually we have utilized for the anti-cancer activity. So there actually the saffron was grounded in a low temperature. Then this powder was actually subjected to 100 to 600 megapascal and 30 to 70 degrees centigrade. It's a water extraction basically. The extract what we obtained, it contains saffronol, picrochrosine and crosine. However, depending upon the temperature and the pressure combination, this composition actually it was varied. So the optimization has been done for the better retention of these saffronol and crosine. Then this extract was actually utilized for the anti-cancer activity. So where actually MTT assay has been done for 24 to 72 hours. So this way actually you can see here the EC50 values are actually lower for HPP treated sample in comparison to the control sample, number one. Number two, with increase in the duration of treatment, like actually it was held for 72 hours, where actually you got the highest efficiency, where actually the EC values were lower. So this way it can be used as a solution for your anti-cancer activity. So application of pressure up to 500 megapascal with a moderate temperature of 50 degrees centigrade. This can be used for the extraction of bioactive compounds from saffron with maximal yield. And the treatment of cancer cells in vitro by saffron extract is dose and time dependent, which has been proved. And as I told, the EC50 value was lower in case of saffron components treatment compared to the extract which is done with the conventional thermal treatment. That means the bioactives which were present are actually having a higher activity in case of high pressure treated ones. So these kind of studies actually, these are in forefront nowadays for the several other compounds also. Similarly, one more study which we did it on hilstaphilates as well as the shrimp, etc. So I'm not going into much of the details. And one of our partners, CFT Kotian, so they studied on yellowfin tuna, where actually 200 megapascal was found to be better, because being a red meat with a higher pressure actually it is getting the color is actually getting lighter. So this is actually not desirable in case of tuna meat. That's why actually for optimization in terms of microbial count, at the same time keeping the quality of the tuna fish, it has been taken about 200 megapascal. Similarly, one example I was telling about the shucking of oyster. So here actually 200 to 300 megapascal was most suitable for the meat shucking, which depend upon the type and size of the oyster. So by treating this one, you are having a dual advantage in terms of microbial reduction. At the same time, the meat can be extracted 100%. So this is actually one of the major outcome from this study. And the same thing, of course, here actually one can see the crab has been treated with high pressure processing, and each and every component can be separated out. That means the complete meat can be taken out, even from the narrowest legs also. So the meat can be taken out. That means 100% meat yield is possible with lower microbial count. And this study has been conducted by Avure at their facility. So this is one of the example of gelation, where actually in a synthetic casing, so the gels can be prepared. So the left side actually it's a control loop, which is actually thermal induced gel, but the right side one is a high pressure induced gel. The major difference between these two gels is actually a soft gel having a higher elasticity, and this is actually having a higher hardness. So this way the soft gels can be created having similar characteristics of thermal induced gels, but the quality will be much superior. And coming to the industry trends, or maybe from the perspective of industry, so increasingly health conscious consumers are demanding better quality, better food quality, such as improved food safety, nutritional value, freshness, and maybe keeping all the flavors intact. And another segment is actually clean label foods, which claim to be natural and fresh, as well as free from the chemical additives, have gradually gained the attention of the consumers. So in all these cases, the HPP it can be combined with, it will have an advantage in terms of extending the shelf life while retaining its natural quality. So these non-thermal processes can maintain the organoleptic properties and nutritional value of the foods, which is not possible with the conventional thermal pasteurization or maybe any kind of thermal treatments. So the widespread application of HPP technology can boost the development of market and market demand for the HPP equipment, because today actually if you see only handful of very few companies are actually manufacturing HPP facility, and the cost of equipment also is quite absorbent. When you are having higher demand, probably more and more manufacturers will be in play, and that actually when the cost of HPP equipment also can be brought down. So HPP has been widely used in the production of packaged vegetables, fruits, meat, seafood and dairy products, and unfortunately in India actually it is very less in terms of application or maybe industrial applications. So HPP technology also can be combined with existing food trends like organic foods, health foods or maybe clean label foods, so that it can boost the market. As already the organic foods or maybe health foods, they are actually having higher cost, but at the same time if you can combine with this high pressure processing, these can be qualifying as a superior quality foods, and will have a completely entering into the market as a separate segment, having a better market potential. Now, coming to the practical challenges in the high pressure processing, one of course thermal effects during the high pressure processing. Although we say there is no temperature rise, but the temperature increases due to the heat of compression. However, this depends upon the initial temperature of the product and material compressibility, specific heat and the target pressure. So if you are having only 300 megapascal target pressure, the temperature rise could be about 9 degrees centigrade. But if you are going for 800 megapascal, so probably it will be increasing up to 24 degrees centigrade. So that way you may have to control your initial temperature so that the thermal induced changes cannot be influencing your product. So heating may lead to the gelling of food components, denaturation of protein, migration of fat in the products. So that's why actually it is not desirable to raise the temperature or maybe allow to raise the temperature. Another, of course, this is actually already we have discussed about the pressurized thermal processing. Another segment actually which is upcoming is organic food, as I mentioned earlier. The consumption preference of consumers for natural organic food as a raw material is reflected in their consumption choices. So while people are looking for these, so these can be recognized as high quality, natural, and at the same time wholesome foods with low risks of any pesticides, because they organic means they are not applying any kind of pesticides or maybe any kind of antibiotics. So when you are having such a good quality ingredient, if this can be treated with high pressure processing for enhancement of your shelf life, so probably these will be categorized as a superior quality, as I already mentioned. So HPP maintains the organoleptic characteristics and nutritional value. Thus, quality of these raw materials directly affects the quality of HPP products. So that way we can have a superior quality foods which can be generated. So therefore, HPP food should be combined with high quality organic foods to improve the growth of both types of foods and to enhance the acceptability of the high price for HPP foods among consumers. Because as of now, HPP product means it is a price intensive. So that's why consumer may be stepping back. But when you look at the combination of this organic, although it increases the price furthermore, but there are people who actually can spend and of course maybe purchasing these kind of products in want of the better quality product and in view of the health consciousness. Similarly, we have health foods also on the anvil. The global gradual adaptation of the preventive healthcare concept, it provides an excellent opportunity for the development of health foods. So brown rice with high GABA content was actually found in with HPP treatment. It has been published in one of the recent journals. Similarly, high pressure treated milk, it contains active immunoglobulins, so they will be having a potential to become the functional HPP products. Similarly, the natural functional materials extracted from the medicinal herbs, plants or maybe animals, like actually the bioactives or maybe phytochemicals what you are extracting, so they can be combined with the HPP products. Other way, if you are going for after addition of these bioactive compounds into any of the products with thermal processing, so at least 30 to 40% might have been lost. So whereas HPP can retain most of them, although there will be little loss, but overall actually these can be considered like actually well retention. consumers have accepted the commercially available health foods and their high prices. So maybe it will be adding some more, but these can be considered as a potential health improvement products. So therefore, an important strategy in HPP product development for increasing the acceptability of HPP products is to maintain the original flavors, reduce the additives or maybe no additives rather, and increasing the healthcare functions of various products. So while in health food with HPP combination can retain all these, so these can be considered as a best possible products in the quality category. Now another application which I already mentioned, so the pre-treatment before extraction. So this HPP treatment can improve the it can modify the permeation of the cell. That way actually the mass transfers can be enhanced. So that way the release of extracts are actually much higher and of course with a good quality. So this way the pre-treatment before extraction is considered as one of the potential application in the current scenario. So in the future, HP will become an important pre-treatment step in the research and development of components with healthcare functions for improving the production performance of the functional components in the food and pharmaceutical industry. One specific example which I already shown, where actually there is so the application of saffron extracts. So that's actually where we are getting a good quality extract which can be used as a functional component. So high pressure processing has been successfully used to extract various bioactives like collagen from fish skin, flavonoids from propels. So this way actually we have several of such examples are there. And clean label products is another segment where of course there is no, it is free from any kind of chemical additives and simple ingredients, probably minimally processed. Even this HPP processing also can qualify for such kind of minimally processed, and it is of course free from chemical additives which we have already learned, and in simple ingredients that of course we can formulate. So owing to a global trend towards these clean label safe products, simple formulations and limited additives, the market for clean label products is undergoing a steady and continuous growth, and the high pressure processing technology can add to it, manufacturing the clean label products as it reduces the use of additives while maintaining the desired food quality and microbial safety. So these are actually a couple of upcoming areas which can be tapped. So another potential research area is of course effect of high pressure on bioactive compounds and micronutrients, bioaccessibility and bioavailability. So far certain studies which are available on bioaccessibility and bioavailability, this shows some kind of mixed result. For example, in carrot actually it has been shown the bioaccessibility has been improved, but in case of beetroot it was other way. So this way the mixed results they are actually leading to kind of confusion. So there is a need to study the influence of high pressure on improvement of the bioaccessibility and bioavailability so that the products actually can be considered superior. So the other one actually these are having influence on allergenicity of the food also. So for example, the most frequently reported food allergies are allergies of bovine milk, eggs, apple, peanut, etc. The HP treatment can give rise to structural change in proteins, and therefore it has been used to alter the conformation and allergic potential of the food proteins. So furthermore, this HPP can show potential to reduce the allergy risks of some foods without eliminating the allergenic proteins themselves, but through extraction or maybe release of the membrane-bound allergens into the environment where they can be removed or maybe attacked by the hydrolytic enzymes. So this is actually one specific path of reducing your allergicity. So high pressure processing has been reported to reduce the allergenic potential and the risk of a number of products. So primarily the nuts, maybe in certain cases like fruits and vegetables, or maybe dairy products, and as well as the seafoods also, it has been researched, and of course people have reported. So that way it is having good potential. So coming to the other challenges, the mechanisms of bacterial inactivation, although people have described certain mediation like the permeabilization and cell lysis is one of the mechanism people have postulated, but it was not true in all the cases. So that's why the mechanism of bacterial inactivation has to be deeply understood. Similarly, the bacterial spore inactivation, when it is having a most wear-resistant nature, so that also needs to be studied thoroughly. And the food composition and its interaction with the packaging has not been studied much, so this needs and of course much study. And similarly, the modeling of microbial inactivation and combined effect of pressure, time, and temperature. In most cases, actually, people have applied a simple what I can say, first order reactions, and these actually fails in many cases, and subsequently people have used a viable distribution also. And of course, when you are having the combination of pressure, time, and temperature, this actually can be well described by elliptical models or maybe some kind of biphasic models, etc. So these kind of studies are actually required for each and every commodity, particularly where we are having baro-resistant, either in terms of microbial inactivation or maybe enzyme inactivation. Similarly, the limited information is available on the changes of the changes to food systems, enzymes, and microorganisms during the high pressure processing. What's happening exactly during the ongoing process of high pressure, and sometimes actually this has been studied through some kind of optical sensing, and one of such facility has been developed at Ohio State University by Dr. Sudhir Shastri, and these actually require such kind of developments so that in situ measurements and maybe through some kind of log we can actually get the data so that these can be analyzed and maybe understood the complete picture. And coming to some of the engineering challenges are fabrication of high pressure vessels to handle large volumes of the food and also to withstand the high pressures. So as of now we are having the largest volume is 9,000 liters and maybe smallest volume is only 35 ml, and of course which can go up to 1400 megapascal. Whereas the largest volume system is having only capability of 100 megapascal. So both needs to be improved. So with high pressure, the volume need to be improved, and with the high volume, the pressure range need to be improved. So that's the engineering challenges as far as the we are concerned. The pressure vessel should have a short cycle. It should be easy to clean and of course safe to operate with accurate process protocols. And of course, the development of a continuous process at a low cost or maybe low capital as well as the operational cost is of course another challenge. Although continuous processes are being developed, but this is actually possible only for the liquid foods. Maybe this is again has to be looked from solid foods perspective also. Some of the scientific challenges are lack of kinetic data, which I already mentioned, minute understanding of the mechanisms involving the high pressure effects of food systems, limited knowledge on the role of food constituents, storage related changes, and pressure treated products. And technical challenges of commercial applications of high pressure technology includes material handling, process optimization, variations in the compositional parameters, as well as the package design, which is actually very, very crucial. And certain engineering aspects to be dealt with are process inhomogeneities, as it was proved in many cases, the heat transfer is actually not very uniform. And similarly, in certain cases, although we say it is the pressure is transferred uniformly and instantaneously, but many cases the distribution of the pressure has been inhomogeneous. I mean, it was not actually homogeneous because of the compositional influence. Like actually, you are having a very hard object inside, like a chicken leg piece. So these are actually some of the variations or maybe inhomogeneities people have identified, and those needs to be thoroughly understood and maybe studied. And coming to the industry challenge, the material handling and package design, sanitation and cleaning, bulk or in container processing. So far actually we are having only small packs, but you need to actually develop the systems for the bulk container packaging also, processing also. Similarly, high pressure, short time or maybe low temperature, long time processing. These needs to be studied. Heat transfer within the pressure transfer medium, temperature distribution within the pressure vessel, and even the pressure distribution within the food material. So due to the differences in the complexity which I mentioned just before. Okay. And some of the obstacles for the implementation of high pressure processing as on today are low level of public knowledge, attitude of public administration, looking at the legal risk, and the image of the high cost. Obviously, anybody who know little bit about it, they always feel that it is a high cost process. And false image of high technological sophistication, although much of technology is actually explored, and less number of suppliers all over the world, as I mentioned, maybe hardly a dozen of people are there around the world. And perception of economical risk. So many times people may be afraid if the system is procured now, so maybe it may be obsolete in a couple of years. So although in last 5 to 10 years there was not much change in the configuration or maybe the system what it is capabilities as well as the specifications, but people actually having such kind of obligations. So it is necessary to offer food companies approved protocols and process validation services like a incubation center where actually they can come with their commodity and they can process and of course go for the test marketing. So that is actually one of the possibility where actually fear in the industry can be removed. Overall, actually the key process advantages of high pressure applications to food systems are the independence of the size and geometry of the samples during the high pressure processing, possibility of low temperature treatment, that is one of the very important aspect, and the availability of a waste free environmental friendly technology, which is actually the concern of today in the industry point of view, and opportunities for effective and relevant utilization of the potential of high hydrostatic pressure centered around the preservation processes, product modifications, processes based on the phase transitions, or maybe membrane permeabilization. But much of the segment is only on the preservation processes, but there are a lot of cross applications are there, including the development of intermediates with improved product characteristics. So that's actually segment one need to explore. So at last, actually, I would like to conclude with the commercial success stories show a great potential which can be used for the development of a diversified value-added food products with novel physicochemical and sensory attributes from the high pressure process. Although high pressure processing may not replace the existing thermal processing in the near future, but it can find its own niche application, and it can become a segment for the elite people at least. So adaptation of this technology would benefit the consumers in terms of improved food safety, shelf life, quality, as well as the availability of value-added nutritional products at a reasonable cost. So with this few informations, just I would like to conclude. These are actually the high pressure products in the international markets which are actually available in abundant, and of course variety of products are available. So probably we must see in India also such a day. So with our combined effects of efforts of such institutions like maybe IIT Kharagpur, CFTL Mysore, DFRL, or maybe these days actually some more institutions like AAU, Anand Agriculture University also, they have a system today, and IFPT Tanjavur, that's NIPTM also, so they have acquired a system. So probably more and more institutes are actually showing interest and they are getting into the this particular novel state-of-the-art technology. So that way probably we will be able to see a day where actually we can see Indian stores also will be having such kind of products. So I would like to express my gratitude to Prof. N Mishra sir and maybe team FCTL for organizing this and inviting me as one of the speakers. And we have learned a lot through NEIP project which has been funded by World Bank. And our team includes, of course, Prof. Mishra sir also, he was one of the co-PA in this project, and of course he also contributed a lot. And among our student folk, Dr. Snehashis, Dr. Neelima, Dr. Barjinder, Dr. Nishant, Dr. Kaunsar, Dr. Lakshmi, all these people have a greater contributions, and whatever the results which I presented, those are of their own research. So thank you very much for having a patience, and I think I have extended my limit also. So sorry for that, and so I could not conclude within the time start given.
No, sir, it was very nice presentation, and we have almost captured each aspect of the high pressure processing, which is quite informative for the audience which has joined.
Also, it is getting lot of appreciation on the chat box, and
yes,
also represented by that there are a lot of questions it has generated among the audience. I think that is just very nice job done, nicely presented. So Siddharth, you can read one by one the questions, etc. I think there are quite a few interesting questions.
I can look here one how I process mushrooms. I think there are first question, right?
yes, Sanjeev Paul has asked.
In fact, mushrooms is one of the commodity which is not suitable for the high pressure processing because of the entrapped air, and of course this entrapped air actually causes a lot of browning. We have of course studied this one in the initial phases, and it was actually down to a lot of brown color, so found it's not suitable. Probably with some antioxidants surrounding the what you can say mushroom, so probably can be treated to minimize this browning effect.
Okay, I think Sanjeev Paul got his answer. There is a next question, sir, from Banasri Manna. Sir, pH is a factor of this treatment, but how? How pH is a factor of this treatment, HPP?
Actually, acidification can reduce the requirement of the process severity. So where actually, let's say in a particular case, which is close to, let us say, neutral, so it may require, let us say, 500 megapascal, but with acidification, we may be able to get the same microbial inactivation at a lower pressure like 300 or maybe 350 megapascal itself, because pH is actually acting as another additive.
Okay, sir. There is the next question from KK Durga Rao. How pressure penetrate inside the packaging?
Actually, inside the packing, it will not penetrate. Basically, we are actually, if it is a solid product, we are going for vacuum packaging. And if it is a liquid product, which is actually packed in a flexible packaging, this pack is actually kept in the vessel, and around the around this package, we are having a lot of fluids. So that fluid will be compressed in the commodities. That's how actually the pressure is being transmitted. Not actually inside the package is basically through this liquid pressure only. It's basically hydrostatic pressurization.
It's like a compression, but pressure does not go inside the liquid.
That's how actually the rupture doesn't occur, so it will be applied uniformly in all the directions. So that's why the package will be intact. But only some volume change will be there, and the post processing, so again the volume may be regained. So that's the reason, like commodities like mushroom, etc., they may not be able to regain the shape because of the collapse of the structure. So that's why those are not much suitable. But in most cases like fruit juices or maybe even cut fruits, etc., it will regain the volume change which is happening. That's about 5 to 15%.
There is one question from Iresh Kumar. Sir, what is the cost range of HPP machine available?
What is the how pressure penetrating?
Cost range of present HPP machine.
Systems. Okay, systems actually these are available anywhere between 1.3 crores to maybe up to 5 crores also, depending upon so what system capacity. And even make up the system also, it is one of the factor, of course, these days. Some of the Chinese systems we are able to get in less than 1.5 crores, that's about 1.3 crores. But the same system, if it is a standard means like Stansted fluid power or maybe NC hyperbaric Avure, those are actually costing about 2.5 crores. Recently, Niftem has acquired, so they have procured for about 2.3 crores, I think. 2.3.
Even if you include the temperature also, like temperature induced HPP.
Yeah, that's also another matter. Actually, this temperature control and the pressurization and depressurization. So the rate of pressurization also can be one of the optional factors. So one can go for a slow mode of pressurization where actually one intense fire is required. But if you like to go for a rapid pressurization, you require more than one intense fire. So in that way, actually the cost also will be increasing. A basic system without heat control so can be obtained for about 1.3 to 1.5 crores. But when you are adding all these control systems or maybe rapid pressurization and monitoring, etc., then probably the cost will be going high to the tune of about 2.5 crores. I am talking about laboratory-based systems. However, industrial-based systems are also available anywhere between 3 crores to even 10 crores. The volume, which is actually from 35 liters to 300 liters.
Okay. So there is a next question from Lubana Sheikh. Are there any Indian industry who are using this technology to process? If not, then wanted to know what is limiting them to use.
Yeah, in only one company in Bombay, there's Raw Pressury, which is using this technology, and of course limited to a couple of fruit juices only, not by anybody. Although ITC was actually sometime back actually they approached, but subsequently looking at the cost of the equipment only, so it seems they have backstepped.
There is one question from Jaya Kumari. Sir, is there any law from government for using novel method? Means any law has made yet for HPP product?
Yeah, in US, of course, US FDA has approved this particular process, and of course, for that matter, many other non-thermal technologies. But in Indian scenario, as of now, probably there is no rule. Maybe Prof. Mishra sir can tell much because he's in FSSAI. So I don't think actually there is any kind of regulation as far as the FSSAI is concerned for the non-thermal technologies.
That is all not yet enforced, but they are working on it. The committee are working.
Okay.
Maybe sir, means if many products comes in the market, then they may make the law.
Yeah.
There is one question from me, Mira. Sir, it is often seen that HPP treated fruit juices tend to ferment faster once opened unless preservative are used. Your comments, please.
Yeah. Actually, the high pressure treated foods, for that matter, any non-normal treated foods, they require chilled storage because we are getting a pasteurization effect only. So that's why we need a chilled storage. And of course, that is one of the obligation also as far as the commercialization is concerned because we need to maintain that cold chain. However, it's being maintained in most cases. And if you are not maintaining, then obviously this fermentation will occur due to the continuous changes which are happening in chemically. Maybe for actually 1 or 2 days it may not be a problem, but for a long term it will be a problem.
Okay, one question from Luana Sheikh. Which technology is being used by so-called leading juice processing manufacturers in India? Why are they not mentioning the technology used on the packaging?
The Tetra Paks probably, which is the predominant sector, so where actually aseptic packaging is the main. And as I told, non-thermal actually only this raw pressure is one particular company who is using. Whereas actually if you come to the normal segment, of course those are all thermally processed only, which are available in the bottling process.
There is one question and comment from Sukumar Devnath sir. It is indeed highly insightful, informative, thought-provoking, and excellent presentation. Sir, is it possible to increase oil content of an edible oil seed after its HPP treatment followed by extraction?
Although I have not studied this one, but the literature says it is possible because the extractability it improves. That's why actually the yields may be better after the HPP pre-treatment, or maybe HPP acid extraction also people are doing. But in case of oil seeds, so probably being treated with a larger quantities, so probably one must look for only the pre-treatment, not for the HPP acid extraction.
There is one question from Hidesh sir. Sir, whether there is some effect of HPP in development of texture of meat alternative? Is any effect? Meat alternative.
Meat alternatives.
Is any effect on texture if we do the pre-treatment of the raw ingredient like?
Actually, as I told, most of these protein-based products actually they tend to gel. So this gelation also, of course, is a part of the structural modification, but the intended structure like your meal maker, etc., that may not be possible, but you will be able to get the gelation. I don't know, maybe subsequently with combination of pressure, temperature, and with a controlled application, that texturized products can be possible. So as of now, actually, I have not seen any literature on this.
There is one question from Anas. Sir, are there any studies on in situ determination of temperature of the product during the HPP processing? Yeah, actually these systems also you can measure the temperature, but there is a provision which is provided. So there is a thermocouple with some kind of binding provision is there. So you can pierce into the packaging material and make a what I can say fixation on both sides so that it will not leak for the pressure, and it will be able to measure the temperature in the middle of the product. Only thing actually we did not get that particular attachment in our system. That's why it's not possible. Whereas CFT Cochin they have acquired and they can actually, particularly it's for liquid foods, actually it is very well possible. There is another question from Sukumar sir. Do you think that HPP treatment shall add higher organoleptic properties to meat after its HPP treatment followed by frying in comparison to same product obtained through pressure frying? Pressure frying? Just to do it. Means sir, if meat after HPP treatment followed by frying. Now actually, let me tell. Actually, there was a study. So this HPP treatment can reduce the oil uptake, and even frying time also it is said to be lower. So this way, the quality attributes can be better after the HPP pre-treatment followed by frying. Although I have not studied anything on this one, but there was a particular research paper which is actually indicates this one because of the puration which is actually created.
So the heat and mass transfer, they are getting improved. So that way oil uptake will be less and lesser amount of time is required for the frying completion.
I think what he wants some yield, increase yield if there are pre-treatment pressure is given.
Yield may not be. Yield may not be.
No, sir. Actually, I wanted to know. Thank you, sir. Thank you very much. I learned a lot. It's an excellent presentation. I learned a lot, many things. Thank you very much. No, sir. What I wanted to know, organizational like juiciness and taste for preference and something like that. So if you compare it, this one, we are having a pressure fryer also, and because the juiciness especially, which can be improved by using the HPP followed by frying. Something
Pressure
like
fryer
that.
means you mean vacuum fryer?
No, sir, pressure fryer. Vacuum fryer actually. No. It is a pressure fryer. Another one, vacuum fryer. You are reducing the actually. You are taking it out. That is specially useful for the snappy type products, so that potato chips line. But if you want to have some juiciness, you want to have a extra apply pressure like pressure frying, like you are doing HPP something like that. But not that range. We don't go that range.
Dr. Devnath, I think in the pressure frying, that the pressure application, it is I think steam pressure.
Yeah, yes, sir. It is something like cooker.
Because it is not a hydrostatic pressure.
No.
So definitely it will have some different effect.
Exactly. I wanted to know the HPP followed by the cooking or frying. Does it give any more this juiciness or the taste profile increase or something? So that we'll follow that one only instead of pressure frying.
You mean to see that the grains that before they are fried, they should be given, if they are given a HPP treatment,
Exactly.
what will be effect?
Yeah, that is also there. So I wanted in case of the meat or chicken, something like that.
Yes, that is an interesting area to be studied. But
I have studied so far. So now if the system is okay with us, now probably we'll be able to.
The system with you will be having vacuum fryer. There it can study it. That is for the potato chips like products. What I want is the juiciness, not the that is a chicken or meat or fish like that.
Yeah, I understand.
There you are putting extra pressure, not taking it
I'll
out.
not be able to comment.
Yes, sir. Thank you, sir. Thank you very much. Very happy to see you after a long time.
Okay.
Very nice discussion. There is one question from Dr. Alok Saxena. Between pulse electric field and HPP, which is more efficient for microbial elimination in fruit pulp?
Pardon?
Who is better, pulse electric field or HPP? Who is better for microbial elimination in fruit pulp?
This actually again, so people have compared, and so in fact, high pressure processing, one major advantage in terms of the quantity which is being treated, you can go for a larger volume treatment. But in case of pulse electric field, there is a limitation with the quantity which is being treated. And as far as the sensory attributes are concerned, in both the cases, people have reported it's actually well retention of the nutritional attributes. And there also the temperature rise can be controlled, the so-called Joule effect, Joule heating effect, that can be controlled. And the porosity is basically due to the electric pulse. So that way, I hope actually, maybe I expect the attribute should not be modified much. But I don't have direct.
Might be difficult to compare that these two processes unless the boundary conditions are specified.
Exactly.
That is what is the type of the food, what are the conditions, because so the boundary condition has to be specified. Then only you can compare. Both give microbial inactivation. Maybe economics wise, if you say that yes, PF maybe little comparatively cheaper like that. Quality advantages maybe in high pressure processing more, but the microbial inactivation, that will depend what are the other conditions in the food and how these things are applied.
So ultimately, actually, we need a final cycle reduction in either of the cases. So to get that one, actually, we may be applying whatever the conditions which are befitting for that. But however, the quality point of view, so probably PF might have a better compared to.
HPP will have to be better,
Yeah. But scalability actually is a question.
Yes.
So Sir, is there any?
EF has certain limitations.
Yes, sir.
Yes, sir. Yes.
I will.
Sir,
Out of the lot of questions.
a lot of person has been covered. Yes, sir.
Now you can take in. Okay. How are you, Dr. Gothwal? You are muted. Yes.
Very good evening, sir. Hi.
Good evening.
Thank
Good
you.
evening.
Very nice lecture by
Good.
Dr. Rao. Is really very good insight he has given. And
Welcome. Welcome.
I think our
See
Dr.
you in the-
Sukumar asked very genuine question. He was very interested in some.
Yes, Dr. Sukumar, he is our regular friendly officer.
Namaskar. Very happy to
Sukumar,
see you.
namaste. कैसे हो भाई? How are you?
I am fine, sir. How are you, sir?
बढ़िया 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 बढ़िया. I'm fine fine.
Thank you, thank you. Thank you, sir.
So,
Very
Siddharth,
happy to
after formal, agar if everything is done,
Yes,
all
sir.
questions are answered, then
Yes,
you
sir.
can take, you can customary.
So, we would like to go for the vote of thanks. I would like to call Prithvi Hyal to do the vote of thanks to Rao sir.
Professor
Prithvi?
Sevak Roy ji, kaise hain sir?
audible, sir?
Okay.
Am I audible?
Yes, you are audible.
Good evening, one and all present here. It is my pleasure to deliver the vote of thanks for the webinar to all the dignitaries assembled here. And firstly, I would like to thank our speaker, Dr. P. Srinivasa Rao sir, for his informative presentation on HPP and for sharing his knowledge and experience about the challenges and opportunities about HPP. And I would like to thank Professor N Mishra sir, who is the coordinator for this webinar series and who made this webinar series available for a wide number of audience, include professors and students, not only from IIT KGP but also from all over the India. And I would like to thank all the professors and audience who are present in here. Last but not the least, I would like to thank our beloved audience for making this webinar series a grand success. Once again, I thank one and all present here and have a great evening. Thank you all.
Okay, thank you, Prithvi. Thank you, sir, for your
Thank you,
presentation.
sir.
Yes. Siddharth,
Thank you.
Yes, sir.
We'll meet.
I think now we have that in today's we have generated really a very good list of our next presenters. एक के बाद एक सर को सबको.
Yes, sir. Yes, sir.
Now, Professor Viswanathan, Dr. Gothwal. Now listen. I think Professor Sevak Roy is there. Professor Sevak Roy, how are you, sir? You are muted. Good. Now, so can we close now? I think.
Yes, sir. Good,
Sir,
sir.
Professor Mishra sir, just 1 minute, sir.
हाँ
Sir,
बोलिए.
now COVID over, sir. Now we can have some physical things, sir. Physically. मैंने कहा ये ऑनलाइन बहुत सारे टॉपिक हो गए सर. अभी कोई फिजिकली भी करिए सर.
हाँ
फिजिकली
फिजिकली भी अभी चल रहा है. अभी नाउ पीपल डिपार्टमेंट इज प्लानिंग एंड एक्टिविटी तो शुरू हो
Yeah.
गया है.
जी जी
But I
जी.
think this is one very important thing which we have कोरोना कोविड पीरियड का दिन रहा है.
जी 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 जी.
I think जब तक कंटिन्यू हो सकता we will continue this because this has reached to a very wider section of society and the beauty is that this was I think 45th.
44.
44 and all this information is available online in the YouTube as well as in our laboratory website.
जी,
And
जी.
we are getting very good feedback from the. In fact, earlier Professor Viswanathan gave very important and interesting feedback. If we can all, because and I have asked some of my scholars if they can do that. All these videos which are available on the YouTube or even Facebook, if they can be put together and put into the format of CD, etc., that will be really a very, very good that collection of the lecture. So I think till my team has strength, we will continue this webinar series, but definitely we will organize offline some event, etc., and some discussion are already going on that has already started. तो आप लोगों के सबके सपोर्ट से एटलीस्ट वेबिनार या वेब सीरीज हमारा हिसाब से तो कंटिन्यू किया जाना चाहिए और हम लोग कंटिन्यू रखेंगे इसको। धन्यवाद विश्वनाथन जी।
Yes, sir.